In this video, we're going to talk about finding the missing measures when our triangle contains expressions instead of just values. Now, our rule for the triangle sum theorem still stands that angle 1 plus angle 2 plus angle 3 equals 180 degrees. The difference is we may have expressions for one or more of our angles. Now, which angle is angle 1, 2, 3? Doesn't really matter. You get to simply choose. So I'm going to, for my own purposes, say that this is angle 1, that this one is angle 2, and this one is angle 3. And again, you get to choose that. Then I'm going to put those values that I was given into my equation. So for angle 1, I said that that is the 3x. So angle 1 would be 3x plus angle 2 right here, I have 4x minus 1. So I'm going to put 4x minus 1 plus, now I have angle 3. Now that symbol right there, we've talked about that. That means that it is 90 degrees. So there's my angle 1 plus angle 2 plus angle 3, and then equals 180 degrees. Now that I have it set up, I simply have to solve the equation going through the steps from my solving equations flowchart. So step 1, do I have fractions or decimals to get rid of? No, I do not. Step 2, do I have distributive property to apply? No parentheses, no distributive property. Step 3, do I have like terms on the same side of the equal sign? Now, once again, you can choose to draw this line, may be very helpful for you to see. And sure enough, I have some like terms. So I am going to do the marking of like terms. So the first term has a variable, it gets 1 underlined. The second term also has a variable, so it's going to get 1 underlined. Now my next term is a constant. It's going to have 2 underlines. And then I have another constant, so that's going to have 2 underlines. Okay, now I'm going to combine those like terms. Now pay attention to signs, very, very important. So 3x plus 4x is going to give me 7x. Now this is where I want you to pay attention. Notice it's a minus 1, it's a negative 1 plus a positive 90. So it's not going to become 91 because it's really a positive 90 subtracting 1 means it's positive 89 that I'm given there. And then I'm going to still equal 180 since that's all I have on the right-hand side. Okay, so I've done like terms. Next question, do I have variables on both sides of the equal sign? Nope, only variable over here on the left. Do I have a constant on the same side as the variable? Yes, I do. I have this positive 89, so I'm going to use inverse operations to remove that. So I'm going to subtract 89 from both sides of that equal sign. All right, when I do these 89s are going to cancel, which leaves me with 7x. That's what I'm trying to do, is ultimately get that x all by itself. And 180 minus 89 is going to give me 91. All right, so now I have 7x equals 91. Last question, do I have a coefficient? I most certainly do there with the 7, so I use division to get rid of my coefficient. And so then again, these 7s cancel, which gives me x by itself, which is what I'm ultimately trying to do. And so when I do that, 7 is going to give me 13. So x equals 13 is my value of x. Now, if I'm needing to find these different angles, then I'm going to take that 13 and put it back in. So for example, angle 1 equals 3x, or 3 times x. So to find angle 1, I'm going to do 3 times my value of x is 13. And so I find that angle 1 is 39 degrees. So that's going to be my angle 1. Now for angle 2, I have the expression 4x minus 1. And again, I'm simply going to put that 13 in for x. So 4 times 13 minus 1. So 4 times 13 is going to give me 52 minus 1. So that means that angle 2 is equal to 51 degrees.